Whatever. Okay. Here we go. Great topic today, linearization. So, um, if we have a function, you guys missed math, didn't you? It's like over Thanksgiving break. What do I need more of? I need more math. Say we have this function f of x. We have a line that's referred to as the linearization of the function at a certain point. Now, I was supposed to draw that tangent. It didn't really happen. And it looks like I can't really erase it, but they would meet at, we'll call this point A. Very difficult to draw perfect. So that means that the y value would be f of A. So we can write an equation for linearization of a function and use it to do important stuff. So y minus, what's my y1 value? What is y1 in this problem? F of A is equal to x minus, what is your x value? A, and then m. What is m? How do we find the slope of that tangent line? Starts with a d, derivative. So the derivative of the function at point A. How do we write the derivative of a function at point A? How do we write that? What does that look like? That would be one way to write derivative, but we want to specify the point and then name the function, f prime of A. So our slope is f prime of A. So that's a formula for linearization of a function. So why would the linearization of a function be useful? It allows us to approximate values of a function within a close proximity of A. So, big idea made simple. Is the line the same thing as the function? No, they are different. However, look at the line and the function in this small close proximity. Are they the same? Not quite, but are they close to being the same? Yeah. So sometimes it's easier to work with a line than it is a function. For example, what's the logarithm of 10? You guys know what log of 10 is? 1. Log of 100? 2. Log of 1,000? 3. Log of 110? Negative 1. Because 1/10 would be 10 to the negative 1, right? Okay, so so you know that log of 10 is 1. But how about the log of 10.1? That would be very challenging to calculate, right? So picture Newton. Newton's doing calculus back in the 1600s. And he's got to come up with some of these values, like, say, the square root of 4.01 or the log of 10.1. How would you do it? He doesn't have a calculator. He would use calculus. And he would use linear approximation. Every single AP test I've done, I've seen a linear approximation question on it. You spend one day in it, you guys will know it well. Find the linearization of the following functions. Piece of cake, upside down. What we do is we find the slope, we find the point on the line. My function is y equals 4x squared minus 1, and we are looking at an x value of 1. What is the point on the line? 1, what? 1, 3. Just plug it in. 1, 3. How do I find the slope? Derivative of 4x squared minus 1 is 8x. So what's the slope? 8. So I have y minus 3 is equal to 8 times x minus 1, or y equals 8x minus 5. We'll do next one, slope and a point on a line. I put a trig one in here because I know how much you love trigonometry. All right, point on the line, the x value is going to be pi over 2. Find the y value, I got to plug that in. What's 2 times pi over 2 is what? Pi. Sine of pi? 0. All right. How do I find the slope? I take the derivative. How do I find the derivative of that function? I use the chain rule. Derivative of the inside. Derivative of 2x. 2. I have a negative 2 times the derivative of the outside. Derivative of sine is cosine. Yeah, so I attach the negative. So now I plug in pi over 2 in order to find the slope. What's 2 times pi over 2? Pi, cosine of pi, negative 1 times negative 2, 2. And then we can write the linearization. We'll do that when we get back, and we will graph it. Have a great lunch. Get some brain food. Okay, here we go. Yeah, let's do it. Okay, so we need the derivative. We got the derivative. It's negative 2 cosine of 2x. And then we need the slope. How do we find the slope? We plug in x over 2. So, I'm sorry, pi over 2. 2 times pi over 2 is pi. What's the cosine of pi? Negative 1 times negative 2 is positive 2. So, we have y minus 0 is equal to 2 times x minus pi over 2. Or y is equal to 2x minus pi. Now, to make my point, I'm going to graph this. So I go to y equals, I have the original function, negative 2, or negative sine of 2x, and then the line, 2x minus pi. And if I graph this in a normal, window, standard window, you can see there's my sine graph. And then watch this line. Is the line the same as the sine function? It is the same. No, but around that spot of x equals pi over 2, if I change my window to x being 0 to, say, let's go 4, and my y from negative 2 to positive 2, you tell me, so as I zoom into a very close proximity, do they look like they are the same right here? Yeah, they sure do look like they're almost exactly the same. And so we can use those for estimation values. So here's the type of problem you get on the AP exam. This is what we're going to try right now. It says find the linearization of f of x equal to 4 minus, or square root of 4 minus x. Use it to approximate the value of square root of 3.99 and square root of 4.1. Provide a drawing to determine if the approximation is an underestimate or an overestimate. Again, put yourself back in Newton's situation. He's formulating calculus. And as he's doing so, he's using it for different purposes. If you want to be able to find the square root of 4, that's easy. It's 2. Everybody knows that. The square root of 3.99, you reach for your calculator. Well, what if you don't have your calculator? Just less than 2, exactly. But by how much? And that's what we're going to try to figure out right now. So, in order to find the linearization of this, I need to find the slope and the point on the line. Now, identifying the point on the line, we're not given an x value, are we? It can. You can choose x to be 2, x to be 8, x to be 20. But we want x to be 0. Why? Because the square root of 4 we can calculate. And furthermore, the square root of 4 is very close to the square root of 3.99 and square root of 4.1, right? So that's why we choose x equal to 0. Yeah, you'll find out what you would plug in to make it that. So I've got 0. So what's my y value? 2. So my slope is going to be, well, I got to take the derivative. In order to find the derivative, I have to use the chain rule. So I have 4 minus x on the inside. Outside is u to the 1/2. Derivative of u to the 1/2. 1 over 2 roots of u. And derivative of 4 minus x, negative 1. Yep. Multiply those two together. And we get. Very good. So negative 1 over 2 times the root of 4 minus x. I plug in what value to find the slope? Plug in 0. 4 minus 0. Square root of 4 times 2, 4. So negative 1, 4. So therefore, the linearization, so we've done the first part, the linearization is y equals negative 1/4 x. And 0, 2 is a y-intercept, correct? 0, 2. So just plus 2. I want to use that to evaluate square root of 3.99. So my x value, I will choose, and my y value. This is the y-intercept, right? 0, 2. There you go. All right. So we want to estimate the approximate square root of 3.99. What would you plug in for x in order to come up with the square root of 3.99? 0.01 or 1 over 100. Right? So now what we will do is we will plug in 1/100th into this, and we should come up with a good estimation for the square root of 3.99. So I have negative 1 over 4 times 1 over 100 plus 2. What is negative 1 over 4 times 1 over 100? Plus, and then 2 written in terms of 400ths will be 800 over 400. And we get 799 over 400. So this would have been helpful to Newton because as you look at this, the square root of 3.99 is 1.9975. Take 799 and divide it by 400. You don't look impressed. Second hour was impressed. How long would you have to spend trying to find an approximation that good? Like, come on, 799 over 400. That's nice, right? Question. Let's do the second one, okay? Square root of 4.1. We'll answer that question right now. Thank you for asking. So follow my line of logic, Miss Anna. 4 minus x. So what is our value for x? What would you plug in for x to get 4.1? Negative 0.1. 4 minus a negative 0.1 or a negative 1 over 10. Right? That's what would give me 4.1. So negative 1 over 4 times negative 1 over 10 plus 2. So that's 1 over 40 plus 80 over 40 is 81 over 40. I'll check it. Well, you got two answers here. One's for 3.99, one's for square root of 4.1. Square root of 4.1 is 2.025, and if you take the 81 and you divide it by 40, you get Sweet. Well, but it says to draw a picture to show whether it's an overestimation or underestimation. So what does the graph of the square root of 4 minus x look like? What does the parent function look like? Yep. So 4 minus x will be shifted to the right 4, and we'll head off to the right or the left? The left. Why? Negative from the x, so it's a horizontal reflection. And so it's at the value of 0, 2 that I have my linearization. So is the line L above or below the original function? It's above the whole time. So therefore, will it be an overestimate or an underestimate? Overestimate. And that's that. Well, we've got negative 1/4 x plus 2, right? So if you were to graph negative 1/4 x plus 2, it would look something like that, up 2 units, tangent that spot. 1, 2, 3. 799 over 400, 81 over 40, and the picture, the graph with an overestimate. Those are your 3 answers for that type of problem. Short assignment today. Enjoy it. Page 210, numbers 5 through 10. I didn't run a copy, so you're going to have to take a picture of the book. And we have a very special surprise today. We have a video that is constructed by the great Sam Moyer and friends that I will put on during work time.